So we're going to start Chapter 7 on absolute value graphs and reciprocal graphs. We'll start by looking at the definition of absolute value. So for a real number a, the absolute value is written as, and then you see these two little bars on either side of the a, those are your absolute value brackets. So as absolute value a and is a positive number. Two vertical bars around a number or expression are used to represent the absolute value of the number expression. And don't get them mixed up with the numbers 1 and 1. It's not like you have like 1a, 1. Okay, like these brackets are bigger than the numbers. Okay. So for example, the absolute value of a positive number is a positive number. Okay, so if you take a look, we have the absolute value of positive 5, that's equal to 5. The absolute value of 0 is 0. And so you put the bars on either side of the 0. Absolute value of 0 equals 0. The absolute value of a negative number is the negative of that number resulting in the positive value of that number. So if you want the negative or the absolute value of negative 5, then that's the negative of negative 5. And remember, a negative times a negative makes it a positive, so it's equal to positive 5. Absolute value can be used to represent the distance of a number from 0 on the number line. Okay, so if we take a look at the number, let's say that our number a is negative 5, then one way that you can think about the absolute value of negative 5 is how far is that number away from 0? And it would be 5 units away from 0, so the absolute value of negative 5 is 5. And then let's say that a is equal to positive 5. Well, then the distance between 0 and 5 is 5, so the absolute value of positive 5 is equal to 5. In general, the absolute value of a number, a real number a, is defined as, okay, and it can be written like this. The absolute value of a is equal to a if a is greater than or equal to 0. The absolute value of a is equal to negative a if a is less than 0. All right, and we're not going to put less than and equal to 0 on this a here because we already have the equal sign on this one. Okay, so I'll split this up and show you with an example. If a is greater than and equal to 0, then the definition of absolute value is that the absolute value of a is equal to a. An example would be, let's say that a is equal to 5, then the absolute value of 5 is equal to 5. Okay, the other half of the definition says this: if a is less than 0, then the absolute value of a is defined as negative a. An example, let's say that a is equal to negative 5, then the absolute value of negative 5 is equal to negative 5, which is equal to positive 5. Okay, so as can be seen from the above definition, the absolute value of a is always either positive or 0, but never negative. Okay, so let's try evaluating some numbers. So determining the absolute value of a number, evaluate the following. So we want the absolute value of 3. Well, this means that a is equal to 3, okay, and so we know that the absolute value of a equals a for a is greater than or equal to 0, okay. So that means that the absolute value of 3 is equal to 3, okay. Now if we want the absolute value of a negative number, then let's remember that by definition, the absolute value of negative a, the absolute value of a is equal to negative a for a is less than 0. Okay, and a in this case is negative 7. So the absolute value of negative 7 is equal to the negative value of negative 7, which is 7. All right, now I wouldn't do that all the time. I mean, I would just write this, negative 7. Absolute value of negative 7 is 7. Okay, but just to show you how it works with the definition. Okay, so try out the next two on your own. Okay, so put the pause button on and try these ones out yourself. Okay, so the absolute value of 9 then is equal to 9, and the absolute value of negative 12 then is equal to positive 12. Okay?